Some people think we might be living inside a computer simulation, not as science fiction, not as metaphor, as a serious hypothesis about the nature of reality itself. This video is about how that idea formed, what it actually claims, and whether there's any way to know if it's true. If you enjoy these deep dives, you can subscribe. It helps more than you think. So, let's begin. The question didn't start with computers. Humans have been questioning the reliability of their senses for thousands of years. Ancient Greek philosophers wondered whether the world we perceive is the world as it truly is. Plato's allegory of the cave suggested that what we see might be shadows of a deeper reality. Descartes imagined an evil demon feeding false perceptions to his mind. These weren't scientific theories. They were thought experiments about epistemology, about what we can actually know. But they planted something, a recognition that experience and reality might not be identical, that consciousness might be fooled, that the structure beneath appearances could be radically different from what it seems. The modern version emerged from a different place, not philosophy alone, but the convergence of computing, physics, and cosmology. By the late 20th century, computers had become powerful enough to simulate simple environments. Video games created worlds with rules, objects, interactions, virtual spaces where things existed only as data. And once you can simulate a world, even a crude one, a new kind of question becomes possible. If we can do this on a small scale, could something else do it on a larger one? In 2003, a philosopher named Nick Bostrom published a paper that gave the idea formal structure. He didn't claim we live in a simulation. He proposed something more careful, a trilemma, 3 possibilities, and at least one of them must be true. The first, civilizations like ours almost never reach a level of technology advanced enough to run detailed simulations of conscious beings. Maybe they destroy themselves first. Maybe the technical barriers are insurmountable. Maybe it just never happens. The second, civilizations that do reach that level choose not to run such simulations. Maybe it's unethical. Maybe it's uninteresting. Maybe they have other priorities. The third, if civilizations frequently reach that level and do run these simulations, then statistically, we are almost certainly in one. Because if advanced civilizations run billions of simulated realities containing billions of conscious beings, the number of simulated minds would vastly outnumber original minds. And if you're a conscious observer, you're more likely to be one of the many than one of the few. This wasn't a proof. It was a probabilistic argument wrapped in conditionals, but it was structured enough to be taken seriously. It moved the conversation from vague speculation into something you could reason about. The timing mattered. Bostrom's paper arrived during a period when physics itself was starting to describe reality in ways that sounded unexpectedly computational. Information theory was being applied to black holes. Quantum mechanics was being reframed in terms of information processing. Some physicists were exploring digital physics, the idea that the universe operates on discrete rules rather than continuous ones. Space and time and matter might not be smooth. They might be granular at the smallest scales. There's a fundamental limit in physics called the Planck scale. At distances around 10 to the negative 35 meters and timescales around 10 to the negative 44 seconds, the usual rules seem to break down. You can't measure anything smaller, not because our instruments are too weak, but because the concepts of space and time might not function below that threshold. Some interpretations suggest reality is pixelated at this level, quantized, like the resolution limit of a screen. Energy behaves this way too. It comes in packets, quanta. Electrons don't orbit a nucleus at arbitrary distances. They occupy specific shells, specific states. Light doesn't flow continuously. It arrives as photons, discrete units. This doesn't mean the universe is literally a computer program, but it does mean the universe has properties that superficially resemble how information is processed. Finite states, step functions, rules. Then there's the speed of light. It's not just a speed limit. It's a limit on causality. Information cannot travel faster than light. No signal, no influence, no change can propagate quicker than about 300 million meters per second. If you imagine the universe as a system that updates its state, the speed of light starts to look like a processing speed. a maximum rate at which the system can compute interactions across space. None of this proves anything. The Planck scale could be a fundamental feature of reality without implying a designer. Quantization could be intrinsic to nature. The speed of light could just be a property of space-time. But these features of physics fit comfortably into a simulation framework. They're consistent with a reality that has constraints, edges, limits, and that consistency is part of why the hypothesis feels plausible to some people. Video games reinforced the intuition. Modern games use rendering tricks to save computational power. They only fully simulate what the player is looking at. Objects far away are simplified. Distant mountains are flat textures. Unseen rooms aren't calculated in detail. This is called culling, and it works because the player can't tell the difference. Reality seems full and continuous, but the underlying computation is selective. Quantum mechanics does something that sounds similar. Particles don't have definite properties until they're measured. An electron's position is a probability cloud, not a point, until something interacts with it. Then it collapses into a specific state. This isn't culling, exactly, but it's a universe that seems to conserve resources. It doesn't compute everything at once. It computes what's needed when it's needed. The measurement problem in quantum mechanics is one of the oldest puzzles in physics. Why does observation change the system? What counts as an observer? Is consciousness required, or just interaction? Nobody knows. The math works. The predictions are accurate to astonishing precision, but the interpretation is still debated. Some physicists think consciousness collapses the wave function. Others think the universe splits into parallel branches. Others think the question is meaningless, and we should just calculate. If reality were a simulation, the measurement problem might make more sense. The system doesn't finalize details until something checks, like a game engine deciding where an object is only when the player looks. It's an explanation that fits. But fitting isn't proof. Lots of ideas fit without being true. There's also the question of fine-tuning. The constants of physics, the fundamental numbers that determine how forces work, seem oddly calibrated for life. If the strength of gravity were slightly different, stars wouldn't form. If the electromagnetic force were stronger, atoms wouldn't bond into molecules. The universe appears balanced in a way that's hard to explain by chance alone. Some scientists point to the anthropic principle. We observe a universe compatible with our existence because we couldn't exist in one that isn't. That's logically sound, but feels incomplete. Others suggest a multiverse, infinite universes with different constants, and we happen to be in one that works. That's also unfalsifiable. A simulation offers another angle. If someone designed this universe, they could set the parameters deliberately, like adjusting settings in a physics engine. Gravity here, electromagnetism there. Dial it in until chemistry works. It's not a scientific explanation, but it's a conceptual one. It turns fine-tuning into an artifact of intention rather than luck. Still, intention implies an agent, a programmer, a civilization, and that just pushes the question back. Who made them? Where do they come from? If they live in a base reality, what are the odds that reality isn't also simulated? You end up in an infinite regress, simulations within simulations, turtles all the way down, unless there's a bottom layer, a true reality. And if there is, why assume we're not in it? Energy is a problem. Simulating a universe in full detail would require staggering computational power. Every particle, every interaction, every quantum fluctuation across billions of light years and billions of years. The energy cost would be immense, maybe impossible. Some have suggested that a sufficiently advanced civilization could harvest the energy of a star, or many stars, or a galaxy, a Dyson sphere, a Matryoshka brain, hypothetical megastructures that convert stellar output into computation. These ideas exist on paper. They don't violate known physics, but they're speculative. We've never seen one. We don't know if they're practical, and even if you could simulate a universe, would you simulate it in full fidelity? Probably not. You'd approximate. You'd cut corners. You'd simulate the observable parts and leave the rest vague. The simulation would be good enough to fool its inhabitants, but not perfect, which raises a testable question. Could we find the seams? People have looked. Some researchers have examined the cosmic microwave background, the afterglow of the Big Bang, searching for patterns that might indicate a grid structure. a pixelation of space-time. So far, nothing definitive. Others have considered whether the laws of physics might glitch, unexpected anomalies, violations of symmetry. Again, nothing conclusive. There's also the idea that the simulation might reveal itself through computational limits. If the system is finite, maybe we could push it to the edge, run experiments that require so much processing power the simulation struggles, but we don't know what those limits would look like. We don't know how the system would respond. It might adapt. It might simplify. It might just be fast enough that we never notice. Consciousness complicates everything. If the simulation is detailed enough, do the beings inside it experience genuine awareness? Or are they philosophical zombies, acting conscious without actually being conscious? Most people assume their own consciousness is real. It's the one thing that feels undeniable. But if your thoughts are patterns in a computer's memory, does that make them less real? If pain is a data state, does it hurt less? Some philosophers argue that substrate doesn't matter. Consciousness could arise from neurons, or silicon, or quantum fields. What matters is the pattern, the process. If a simulation replicates that process accurately, the consciousness it produces would be authentic. Others think there's something special about biological brains. That consciousness requires a specific kind of physical instantiation, that simulated minds would be hollow imitations. We don't know. We don't even have a good definition of consciousness. We can't measure it. We can't detect it in others except by analogy to ourselves. The hard problem of consciousness, as it's called, remains unsolved. And without solving it, we can't definitively say whether a simulated mind would truly experience anything. Physics offers no clarity here. The equations describe matter and energy, forces and fields. They say nothing about what it feels like to be something. Subjectivity doesn't appear in the math. Qualia, the redness of red, the coldness of cold, the feeling of fear, these are outside the domain of physics as currently formulated. Maybe they're emergent. Maybe they require new science. Maybe they're illusions. We don't know. If we are in a simulation, the architects might be watching, or they might have started it and left, or they might not be able to see inside at all. Maybe they set initial conditions and let it run, like a scientific experiment. Maybe they're looking for something specific, the emergence of life, the development of technology, patterns in behavior. Or maybe they're not looking for anything. Maybe the simulation is background noise in a much larger computational project, incidental, forgotten. Some have speculated that we might try to communicate with them, send a signal, build something detectable. But how would you get a message out of a closed system? And even if you could, would they care? Would they respond? The asymmetry is vast. We might be as significant to them as bacteria in a petri dish. There's also the possibility that the simulation is layered, that the creators themselves are in a simulation, and their creators are too. That consciousness exists in a vast nested hierarchy, with no way to determine your level. This is where the hypothesis starts to feel less like science and more like metaphysics. It becomes unfalsifiable. Anything could be explained by adding another layer. Any anomaly, any mystery, any gap in understanding. It's not helpful as an explanatory tool if it explains everything equally. Real scientists have mixed feelings about the simulation hypothesis. Some think it's a fun thought experiment, a way to explore the limits of knowledge. Others find it pointless. Unfalsifiable claims aren't science. They're philosophy at best, distraction at worst. A few take it seriously. They think the Bostrom argument has weight. They think the computational nature of physics is suggestive. They think it's worth investigating, even if the odds are low. But investigation is hard. You can't design an experiment that definitively rules out a simulation. Any result could be explained away. The simulation could be sophisticated enough to hide itself. It could intervene when you get too close. It could rewrite your findings. It could rewrite your memory of the findings. There's no upper bound on the capabilities of a sufficiently advanced simulator, which means there's no lower bound on what counts as evidence against it. This is why some people call the hypothesis a modern version of solipsism, the philosophical position that only your own mind is certain to exist. Everything else could be illusion. Solipsism is logically unassailable and practically useless. The simulation hypothesis risks the same fate. Interesting in principle, impotent in practice. Still, it affects how people think. Once you've considered the possibility, it lingers. You notice the pixelation of reality, the way memories are fuzzy, the way time seems to skip, the coincidences that feel programmed. None of this is evidence. Human brains are pattern recognition machines. We see faces in clouds, intention in randomness, but the feeling persists, a low-level unease that maybe things aren't as solid as they seem. For some, it's comforting. If this is a simulation, maybe death isn't final. Maybe the system backs up your data. Maybe you get reloaded elsewhere. Maybe suffering has a purpose, part of a design, a test, a story. These are hopes, not hypotheses. But hope is what draws people to unfalsifiable ideas. For others, it's destabilizing. If nothing is real, why does anything matter? If your choices are scripted, are they yours? If pain is just a signal in someone else's computer, does it deserve moral weight? These questions dissolve on inspection. Even in a simulation, your experience is real to you. Your decisions feel chosen. Your pain hurts. The substrate doesn't change that, but emotionally, it's harder to shake. Philosophers sometimes distinguish between the simulation hypothesis and the dream hypothesis. If you're dreaming, the world vanishes when you wake. If you're in a simulation, the world persists independently. Other conscious beings exist. Causality holds. Physics works. The simulation is a shared, stable environment. This distinction matters for ethics. In a dream, nothing you do affects anyone else. In a simulation, your actions have consequences. Other minds are real. Morality still applies. The hypothesis also intersects with theology. If there's a creator of the simulation, they resemble a god. Omniscient, potentially. Omnipotent, relative to us. Able to intervene or not. Some people find this overlap appealing. It offers a modern framework for ancient questions. Others find it reductive. Comparing a deity to a programmer seems to trivialize both. Religious traditions have long claimed that the material world is less real than a higher plane. Hinduism speaks of Maya, illusion. Buddhism teaches that attachment to the physical leads to suffering because it's impermanent, contingent. Christianity places ultimate reality in the divine, with earthly existence as temporary. These ideas don't map perfectly onto the simulation hypothesis, but the resonance is there. A recognition that appearance and essence might diverge. Yet the simulation hypothesis is not a spiritual claim. It doesn't offer salvation or meaning. It's a technical conjecture about the structure of reality. Whether it's true or false doesn't tell you how to live. It doesn't prescribe values. It doesn't promise anything. It's neutral in a way that traditional metaphysics rarely is. There's a version of the hypothesis that focuses on partial simulations, not the whole universe, but individual minds. Maybe your consciousness is the only real thing. Everything else, the people, the world, the stars, is generated around you. This is called a solipsistic simulation. It's even harder to disprove than the full version, but it's also deeply lonely. And it seems wasteful. Why simulate an entire universe just for one observer? Why make it consistent? Why make other people behave as though they're conscious? Occam's razor suggests simpler explanations are more likely. A shared reality, where everyone is. Real is simpler than a reality custom-built for you. But simplicity isn't proof. Reality doesn't owe us elegance. Some technologists think we'll settle the question by building our own simulations. If we create conscious beings in a virtual environment, we'll know it's possible. And if it's possible, Bostrom's logic applies. We'd be more likely to be in a simulation ourselves. But creating digital consciousness is far beyond current capabilities. We don't know how to make a mind from scratch. We don't even know how our own minds work. Artificial intelligence has advanced rapidly, but it's not clear that current systems are conscious. They process information, they produce outputs, but do they experience? Do they feel? We can't tell. If we ever do create conscious simulations, we'll face profound ethical questions. Would we have the right to turn them off, to reset them, to let them suffer? If they're genuinely aware, they'd have moral standing. We'd be responsible for them. Their well-being would matter. This isn't hypothetical for them. It's their existence. And if we're in a simulation, the same logic applies upward. Whoever made us might be grappling with the same dilemmas, or they might not care. Morality could be species-specific. What seems obvious to us might be irrelevant to them. They might not recognize us as conscious, or they might have different values, alien ethics, incomprehensible priorities. There's no guarantee that intelligence and compassion correlate. The simulation hypothesis doesn't predict anything. It doesn't give us new tools. It doesn't help us cure diseases or build better technology. Its value, if any, is conceptual. It forces us to think carefully about what we mean by reality, what we mean by existence, what we mean by truth. These aren't idle questions. They shape how we interpret science, how we approach consciousness, how we make sense of our place in the universe. But interpretation isn't evidence. You can frame the same facts in multiple ways. Physics looks computational if you want it to. It looks continuous if you prefer. The data doesn't choose sides. We do, and our choice often reflects our prior intuitions more than the evidence itself. There's also a risk of motivated reasoning. The simulation hypothesis is seductive. It offers an answer to big questions without requiring much. No experiments, no data, no risk of falsification. Just a narrative. And narratives are easier than science. They satisfy the urge to understand without the labor of understanding. This is true for many metaphysical claims. They feel explanatory without doing explanatory work, yet dismissing the hypothesis entirely might be premature. Unlikely isn't impossible. We've been wrong before. Ideas that seemed absurd became foundational. The Earth orbits the Sun. Time is relative. Space curves. Particles are waves. Each of these violated intuition. Each seemed implausible before evidence accumulated. The simulation hypothesis lacks evidence now. That doesn't mean it always will. What would evidence look like? Maybe a message embedded in the cosmic microwave background, a sequence of prime numbers, something clearly artificial, maybe a glitch that repeats, a violation of physics that can't be explained, maybe a direct revelation. The simulators contact us, tell us the truth, offer proof, or maybe nothing. Maybe the hypothesis remains forever beyond reach, a question we can ask, but never answer, suspended in uncertainty, neither proven nor disproven, just there, hanging over every claim about the nature of things. And maybe that's fine. Not every question needs resolution. Not every mystery requires a solution. We live in a universe we don't fully understand. We experience consciousness we can't explain. We observe patterns we can't predict. The simulation hypothesis is one more entry in a long list of possibilities. It deserves consideration. It doesn't demand belief. What we can say is this: the world behaves as though it follows rules. Those rules are mathematical. They're consistent. They're discoverable. Whether the rules are fundamental or programmed, they work. We can use them. We can build with them. We can predict with them. That's enough for most purposes. Curiosity pushes us further. We want to know not just how things work, but why. Why these rules and not others? Why anything at all? The simulation hypothesis offers an answer, but so do other frameworks. Multiverse theory, eternal inflation, quantum fluctuations, theological creation. Each has its own logic, each its own gaps. The honest position is uncertainty. We don't know what kind of reality we inhabit. We don't know if that question is even meaningful. We have theories, conjectures, thought experiments. We have math that describes patterns and physics that predicts outcomes. But the deeper layer, the ultimate nature of it all, remains obscure, and perhaps that's appropriate. We're embedded in the system, trying to understand it from the inside, like a character in a novel trying to deduce the author. The tools we have are the tools the system provides. Our logic is its logic. Our measurements are its measurements. We can probe, we can test, we can theorize, but there may be limits to what any internal observer can discover. So we keep looking, we refine our instruments, we ask better questions, we challenge assumptions, not because we expect a final answer, but because the process itself is worthwhile. Understanding, even partial understanding, expands what we can do, what we can imagine, what we can become. The simulation hypothesis won't go away. It's too compelling, too well matched to our technological moment. As computers grow more powerful, as virtual worlds become more immersive, as artificial intelligence approaches human capability, the analogy will strengthen. We'll see more of ourselves in the universe, more of the universe in our creations. But analogy isn't identity. Resemblance isn't proof. The universe might look computational without being a computation. It might have information-theoretic properties without being information. The map is not the territory, and the territory might not be map-like at all. In the end, we're left with experience, the feeling of being, the sensation of existence, the flow of time, the presence of thought. These are immediate, undeniable, at least to ourselves. Whether they're produced by neurons or code, they constitute our reality. And in that sense, the substrate doesn't matter. What matters is the texture of the experience, the richness of it, the meaning we find in it. The simulation hypothesis asks whether any of this is real, but real is a strange word. It shifts depending on context. A dream feels real while you're dreaming. A story feels real while you're immersed. Realness might not be binary. It might be layered, context-dependent, relational. We can't step outside the system to check. We can't compare our reality to some external standard. All we have is this: the world as we find it, the laws as we measure them, the consciousness as we live it. And maybe that's enough. Maybe the question of whether it's simulated is ultimately beside the point, or maybe it isn't. Maybe somewhere, in a detail we haven't noticed, there's a clue, a signature, something that reveals the truth, a crack in the facade. And maybe one day, someone will find it, and everything will change. Until then, we continue, we observe, we think, we question, we build theories and test them. We live our lives as though they matter, because to us, they do. The uncertainty doesn't paralyze us. It motivates us. There's something beautiful in not knowing, in the openness of it, the possibility. We might be in a simulation, we might not be. Both options are strange. Both raise questions that spiral outward into deeper questions. The universe is vast and old and mysterious. Our understanding is recent and incomplete. We've learned much. There's more we don't know, and maybe that's the best place to leave it. Not with an answer, not with certainty, but with an appreciation for the question itself, for the fact that we can ask it, that we can think about it, that we can turn our minds toward the nature of reality and wonder. That capacity for wonder, that drive to understand, that's real, whatever the substrate. That's human, whatever the context. And in a universe that might be simulated, or might be fundamental, or might be something we don't have words for yet, that's enough to build on.